believes in addressing health from all angles: biochemical, biological, physical, mental, emotional, environmental, to provide comprehensive care. And today, Stacey will be talking about nutritional dark matter. So please welcome Stacey.
Thanks, Ali. We didn't intentionally match today, by the way. You're looking very smart today, Ali. So, before I kick into this very exciting topic of nutritional dark matter, I just wanted to say a big thank you to, I know he's not here, Matthew, Sadie and Georgie and everyone for pulling this together. I can't even imagine what was involved in that process. So hats off and thanks for having me here. Also, one of my beliefs is that I have always believed that many of our nutritional solutions lie in the paddocks of our very best producers. So it is sort of a pinch me moment today, actually, because looking out at so many of the country's most amazing producers, honestly, it's very cool for someone like me to be standing here talking to all of you. So that's awesome. The other thing is I do have notes because mostly my brain's a little scattered because I literally arrived about an hour and a half ago after 36 hours in transit in airports and not a lot of sleep last night. So, just excuse me for that. Now, does anyone know of Adam Grant or heard of Adam Grant? Yeah, so he's written a book called Think Again. He's an organisational psychologist and author. And he once said, if knowledge is power, then knowing what we don't know is wisdom. And so I certainly gained more wisdom in researching the topic for this talk, nutritional dark matter. And so I hope that at the end of this you feel a little bit wiser as well. All right, now I wanted to start by basically taking a walk down memory lane, because I think that the evolution of Western nutritional medicine is actually, it's good to reflect upon. Because we're sort of really heading into new terrain, I believe. So let's take a little bit of a walk down that memory lane. So in the 18th century, you've all probably heard of this guy called James Lind, and he discovered that citrus fruits basically prevented scurvy. So he was one of the first people to basically put together this link between what we eat and a particular disease state. Then in the 19th century, some key phytochemicals were discovered that we still rely on heavily today. So morphine, nicotine, codeine, and the world's most widely consumed drug, caffeine. Then in the early 1900s, there was this biochemist by the name of Casimir Funk. Very cool name, I think. But he pioneered this concept of vital amines, and we now call these vitamins. So what he was doing was looking into basically the link between conditions like beriberi, which was a deficiency of B1, and pellagra, which was a deficiency of B3. So he was a bit like James Lind. He started to sort of put together these associations between, widespread disease and what we ate. And so in the case of, of this term vital amines, this is actually the genesis of vitamins. So this is where the word vitamins actually came from. And then in the 1930s, so this was the Great Depression era. This was a time when malnutrition was basically the biggest concern. And so the priority from particularly a governmental perspective was basically keeping people alive. So it's very different to the situation we find ourselves in today, when overnutrition and obesity and modern diseases are more of a concern. And so these things called the dietary reference intakes were developed. Now, the dietary reference intakes later became the RDIs, and you've all heard of the RDIs. So the RDIs still now form the crux of, I suppose, the standard conventional dietary recommendations. And interestingly, in some ways we haven't really moved on, because, for example, the RDI for vitamin B3 is still the same as it was in 1912. And so the RDIs were really designed to keep us alive. Like the RDI for vitamin C, is to prevent scurvy. It's not to help with so many of the other things that we know vitamin C can now help with. And then moving forward, in the mid-1900s, there was more of a connection between minerals and disease associations, so calcium and osteoporosis, iodine deficiency and goiter, low iron and anemia, for example. And then in the late 1900s, or probably between the mid and the late, some of our like omega-3 fatty acids started to be looked into more, so the lipid side of things. And also minerals like zinc and selenium, they're sort of the new kids on the block. Like they weren't really looked into until the 60s and 70s, which really wasn't that long ago when you think about it. And then in the late 1900s, there was this broader recognition of these things called phytochemicals. So then there was thought to be maybe dozens, perhaps hundreds of these phytochemicals in food, and they were simply just coined antioxidants. And then in the 21st century, so particularly in the last decade or two, particularly with the advent of AI and computational techniques and metabolomics and technology essentially, there's the discovery of this dark matter, essentially the chemical complexity of food. And there's more of a food matrix focus moving forward because we understand that food is more than the sum of its parts, essentially. And so we've sort of simplified nutrition a lot. So why am I sharing this with you? Because I think moving forward, we're probably going to see a new vocabulary around food and nutrients specifically. I think moving forward, hopefully how we study nutrition will actually be quite different because we understand that these things now work holistically and synergistically rather than in their isolated parts. And so you get a very different outcome when you study them in such a way. But I suppose if there's one thing that I am very clear on after a couple of decades in this field now, it's that we have severely underestimated the complexity and intelligence of food, essentially. So I'm going to dive into a little bit of that complexity. Now, I won't dwell on this too much, but I just wanted to do a quick sort of 101 of nutrition because I'm going to be talking a lot about these secondary metabolites today and the importance of them, but that's not to say that the others aren't really important, obviously. But I do think that the lion's share of attention, particularly nutrition, has been given to carbs, lipids or fats, proteins, vitamins and minerals, as you could see in that timeline over the past 100 or so years. And John Kempf says that if we are going to have a legitimate conversation about food as medicine, this is where the medicine lies. And he's talking about the secondary metabolites. Now, he also says that who's done his plant health pyramid course? Yeah, so it's online, it's fantastic. And he basically says that the goal is actually to have high levels of all of these secondary metabolites in food. But when you do it in such a way, when you're building those biological systems underneath and you're doing it in such a way where you're actually basically building thriving microbial communities, what's happening is that you're actually not only getting higher quantities, but you're getting better ratios of these as well. And you're getting better ratios and profiles. So you're not getting so much of, say, the phytic acid in plants, which is considered to be more of an anti-nutrient, so less of a favourable secondary metabolite to have in food, for example. So I think that's a really important thing because some of these secondary metabolites can get a really bad rap. But I think it's a bit, again, it's thinking holistically about them and knowing that really, I agree with him that a lot of our medicines lie in these secondary metabolites. In fact, about 25 to 30% of all pharmaceuticals are based on these secondary metabolites. So I also think before we dive into the secondary metabolites and the dark matter even more, just to remind you that we eat food and not nutrients. And what happens is when we, say for example, study something in an isolated way or consume something that's an isolated extract of a plant. So for example, the isolated extract of the willow tree is salicylic acid, aspirin. When you consume aspirin, you're consuming a different thing to if you consumed an extract of the entire plant, for example. And so traditionally how we've studied nutrition is in this isolated way, right? Like we've gone, oh, there's the B1, there's the B3, there's the omega-3 fatty acids, whatever it is, there's the calcium, there's the iodine. However, in studying this dark matter or learning more about the chemical complexity of food, we've actually understood more that they work via this sort of entourage effect, essentially. So very synergistically. So you cannot really isolate them and get the same result. And so an additive effect is 1 + 1 = 2, right? A synergistic effect in this food is 1 + 1 = more than 2. And so I think that's just a really important point to take into consideration, that I think one of the benefits of diving into this chemical complexity of food and really just being clear that we still don't know a whole lot about it, is that we have to understand, that it's working very holistically via this sort of synergistic entourage effect, which in herbal medicine we've known for some time. And this really awesome paper actually highlights this as well. In an effort to uncover the magic bullet, scientists inappropriately studied nutrients in a drug-like context. Unlike drugs, nutrients do not function in isolation and have beneficial effects on multiple tissues and organ systems. A narrow focus on a single or primary outcome measure is not practical and does not fit the nutritional context. So again, take home here is we eat food, not nutrients. All right, so let's go to the dark side. All right, so in terms of dark matter, it's essentially a term that has been borrowed from genetics. So at one point, scientists believed that about 98% of our DNA was essentially useless and coined it junk DNA. Has anyone heard of that term, junk DNA? And it now turns out we know about 2/3 of that junk DNA is actually linked to diseases, essentially. So it certainly wasn't useless. And it certainly was there for a reason. And dark matter is a little bit similar in the sense that we're still we know it's there, but we're still unpacking exactly what it's doing from a human health perspective. I think there's more clarity about what these secondary metabolites are doing from a plant physiology perspective and a growing perspective. But from a human health perspective, we are still unpacking that, essentially. So dark matter is basically, what it's referring to is this vast array of unmapped and previously unidentified secondary compounds or chemicals in food. And these are compounds that aren't tracked by mainstream nutritional databases. So we traditionally track 150 to 200 different compounds in food. The starches, the sugars, the fatty acids, the amino acids, the vitamins and minerals, for example. We don't necessarily track these thousands and thousands of other compounds found in food. And so there was a study that came out in 2019 that was quite a landmark paper that said that, hang on a minute, so it was a network scientist and a physicist from Harvard, and he started looking into, from a systems-based perspective, let's look at food and see what the different sort of networks and even flavour profiles of food were. And he was expecting to find literally a handful of nutrients, and what they found was 26,000 different chemical compounds, natural chemical compounds found in food. This was in 2019. Fast forward to 2024, and this paper now shows that his team has shown there's over 139,000 different molecules found in food. So we've gone from thinking literally 20 to 30 years ago that there was a couple of dozen maybe to hundreds, to thousands, to tens of thousands, to hundreds of thousands. So you can totally see where we're headed with heading to the dark side with nutrition and trying to map this as well. So for example, garlic is one of the foods they looked into. So when they looked into garlic, there was 67 known compounds that they could identify, and they knew what they did in garlic. There was 5,654 compounds that were unmapped and unidentified as well. So you can see that there's a lot there to these chemical compounds that still, that they're still uncovering. In terms of, another example is basil. So when they looked at basil, they found that there was 146 quantified or known nutrients in that basil, and there was 2,047 unquantified and unknown, 2,047 unknown, unquantified molecules. And that's already pretty staggering, but I think when we factor in Dan's work, for example, my question then is, well, that's the garlic that they've tested in that lab in the UK, for example. It's my understanding that my garlic in my backyard or my basil is going to have a pretty different chemical profile. And so this task of mapping this dark matter, is massive because there is so much variation in food. So if that's what we learn from it, then I think that's a good thing to appreciate, the variation. So what do phytochemicals do for human health? Well, phytochemicals essentially are considered non-essential nutrients. What that means is they don't have an RDI. So I talked about the RDI for B3 being pretty old. There's no RDIs for these phytochemicals, for example, but they are seen as health promoting, but they're not necessarily life sustaining. And same is true for plant health from my perspective as well, my understanding there. Now, in terms of our understanding of them, we used to just think they're antioxidants. So when I was studying, 15 years ago now, we were taught that they basically donated electrons and scavenged free radicals, and they, quenched the bad guys, and basically then we had less oxidative stress in our system, and that's how they worked, just purely as antioxidants. But they certainly do a whole lot more than that, which I think is very cool. Now, unfortunately, because of Qantas and Virgin, I wasn't here for Professor Jacka's talk this morning, but for those of you that were, I won't go too much into this because I'm sure this is something that Felice covered. But basically, we know that these phytonutrients, so polyphenols, there's over 8,000 polyphenols, so it's one of the largest classes of these secondary metabolites. 90 to 95% of the polyphenols that you consume through food. So if you had a green tea, for example, this morning, or some blueberries or mulberries or whatever it might be, 90 to 95% of those are metabolized by your gut microbes. They then essentially excrete another metabolite, which we then absorb. So it's a win for the microbes and it's a win for us. So very powerful modulators of our microbiome. And there's a lot of experts in this field who would suggest that these polyphenols are really more like prebiotics than they are like antioxidants, for us essentially. So I think that's really, really important to understand that they have this very powerful manipulating effect in a positive way on our microbiome. The other thing I wanted to mention here as well is that this is also what happens in the soil, right? Like this is basically a mirror of nature in many ways. We can't have this in our diet if we don't have thriving microbial communities. So it totally makes sense that our microbes are just lapping this up. It really, really does. So it's not surprising in many ways. So what else do we know? This again is just the tip of the iceberg. And I'm sure that if I was to deliver this presentation in 1 year, 2 years, 5 years, 10 years, it would possibly be an entirely different presentation as well. So I'm just going to share a little bit about what we do know about how these not so much antioxidants anymore are working, in our system. So thermogenic and metabolic effects. So we've all experienced this. We've all had chili or cayenne pepper and we've become warm or hot. It's changed our body temperature. And that's because they can have these metabolic and thermogenic effects on our body. And similarly, there's foods that are quite cooling as well. So that's one of the ways they work. The other way is through this antioxidant effect. So yes, absolutely, some of these phytochemicals can be amazing antioxidants for our system. So they can protect our cells, they can help with DNA, and help with the detoxification process as well. We also know they can be chronobiotic agents. So what that means is that they can essentially talk to our body clock and our circadian rhythms. So for example, there's a food called tart cherries, and tart cherries can increase melatonin in our bodies. So that's impacting our body clocks. Caffeine, it wakes us up, right? So it suppresses melatonin, so it impacts our body clock. Appetite regulation and satiety. So again, we've all experienced this. When we've had milk chocolate, really easy to overeat. When we've had a 90% dark chocolate, very difficult to overeat. Why is that? It's not because of the fats or the proteins or the vitamins or the minerals. It's because of the secondary metabolites found in the cocoa. They put a handbrake on the urge to overeat. And this is exactly what they do in animals as well. So Fred Provenz's work has showed this very clearly, that they basically help with this satiety factor for animals too. And same is true for us. So there's a saying in nutrition that quality reduces quantity. And this is where this comes from. Epigenetic modification. So the original researcher who looked into this nutritional dark matter, Albert Laszlo Barabasi, he came at this from a genetic perspective, so network medicine perspective, looking at systems within our genes and networks within our genes. And it was his understanding, and mine too, that we're more than the sum of our parts, right? It's the interactions that determines the outcome. So we could have a car and all the different parts of a car, but if those different parts aren't talking to each other, the car's going nowhere. And it's same is true for genes, and same is true for the body. And so what he's shown is when we put food into that interaction with our genes, we see that, wow, there are so many genes that are silenced and upregulated and downregulated. And so this is a very powerful sort of epigenetic effect of these secondary metabolites. Hormonal influences as well. So there are phytoestrogens found in food. So tempeh and flaxseed, for example, contain phytoestrogens, linseeds as well. So we know that there can be these direct hormonal influences through some of these secondary metabolites, or indirect ones in helping us detoxify certain hormones as well. So sulforaphane, for example, found in cabbage and broccoli and Brussels sprouts, can help detoxify estrogen. So powerful hormonal influences. I'm almost there. Take a breath. And hormesis is another way, very cool way in which these secondary metabolites work as well. Has anyone heard the term hormesis? Jake Chandler, don't answer this, I know you know this. And has anyone heard the term hormesis? And Felice. Eustress? Yeah. So basically it is the beneficial side of stress. It is when we expose ourselves to a certain dose of something and the body becomes stronger as a result of this. So with weight-bearing exercise, we do that because we know that the bones we put the most amount of stress on in a healthy way are the ones that are the strongest. Saunas. Dom's going in the sauna very soon. Heat therapy. So that basically that bit of heat therapy makes us, in small doses, makes us more resilient to environmental temperature changes. So the beneficial side of stress, the upside of stress. So stress isn't all bad, and this is a concept called hormesis. And interestingly, phytochemicals can do this for us as well. So when we consume foods that are very rich in these phytochemicals, what happens is essentially, and to borrow a term from Nicole Masters here, they're tickling the system. They're essentially like stimulating us and tickling us in terms of our immune system and different proteins within our immune system and our different sorts of pathways that make us stronger and more resilient in the face of our environment. That's what they're doing for us. They're tickling our system so we're stronger in the face of our environment. So in some ways, they're basically communicating with us. This is how you need to be in this particular environment. I think there's a huge benefit to local food when we think about phytochemicals in this context as well, because of course they're growing in the same environment that we're living with the same environmental stressors that we are going to be exposed to as well. So there's a sort of local advantage, with food. We also know that a lot of these compounds can be very anti-inflammatory. So curcumin in turmeric, very anti-inflammatory. We used to think that the main anti-inflammatory benefit of olive oil was the fatty acids, but some recent researchers show that actually it's probably more the polyphenols, that the secondary metabolites, these phytochemicals that are actually reducing inflammation. And of course, inflammation, particularly of the chronic kind, is like fertilizer for chronic disease. So it's a very good thing if we get low doses of these anti-inflammatory compounds. And antimicrobial actions as well. So we all know what nature's antibiotic is. Garlic? I know that you know that. But garlic, right, like it's an antimicrobial and it has it's great, for example, for certain like Helicobacter pylori infection. And so this is showing that these compounds, again, of course, because in the plant they're produced often to help the immune system of that plant, right? To help with pests and disease. So of course they're going to have antimicrobial and possibly other antiviral, antibacterial actions as well. So that's just a look at some of the things that they can do. Now I wanted to give you a quick example. That is my beautiful daughter Matilda, and that's her with her little crop of carrots. So when she was 4, she wanted a veggie plot. So we basically gave her a veggie plot and we said, just go nuts, plant whatever you want. So she planted carrot seeds and flowers, and totally overcrowded. We didn't think they'd get watered. We thought it'd be a complete flop. Turns out she's a bumper carrot grower, way better than her mum and her dad. And we save those beautiful seeds and replant them every year and get great carrots every single year. Now, in those carrots is a class of secondary metabolites or phytochemicals called carotenoids. We're all familiar with this concept of carotenoids and the term carotenoids found in carrots. They're found in many other foods that are yellow, including animal foods like ghee and butter as well. But interestingly, we have receptors for carotenoids in the human ovary. So we have about 13 to 14 different types of receptors in the human ovaries for carotenoids. And when you look at that particular part of the human ovary, it's yellow, and that is because of the concentration of carotenoids in that tissue. Now, that part of a woman is really bloody important because it's the corpus luteum that basically is like the empty shell in the ovary after the egg has been released during ovulation. That corpus luteum produces a hormone called progesterone. And progesterone is critical for healthy conception and fertility generally. It's critical to reduce PMS symptoms. It's critical for a smooth perimenopausal transition. It is a really important hormone. And this is where it comes from. And wouldn't you know it, carotenoids are really essential for the health of that tissue. And there is research to show that people who consume more carotenoids have less ovarian aging, essentially. The ovaries age at a slower rate, and a lower incidence of conditions like endometriosis as well. So the way that I think about it too is that we have these receptors for these phytochemicals all over the body. So sometimes when we think about tasting food, we think we just taste food in our mouth. But actually, if you think about it, we have these nutrient receptors all over the body, like body fat, heart, I believe the brain. But I'll ask the expert very soon. Gonads in men. I'm just thinking of some of the other main organs. But they are literally located all throughout the body. And what that shows is that essentially the body is sensing, what you're eating. It's not just about the gut. It's about all parts of you. And Anne Bickle and David Montgomery wrote a book called You Are What Your Food Ate. And in the end of that book, they say, farming shapes what we become. And I totally agree, because when you look at this, and Dan's work has shown that there is tremendous nutrient variation in, for example, the carotenoid levels in food, then how we farm with those carotenoid levels literally impacts what we become from an ovarian fertility perspective, and that's one example. So I think it's really cool, and again aligns very closely with Fred Provenz's work in terms of understanding that animals have nutrient receptors all over their body as well, and we're finding the same is similar for us. So if we break this down, where I came to with this dark matter and these phytochemicals is that they're not simply bioactive compounds. They are messengers, they are modulators, they are facilitators, and they're catalysts of balance and health. And they engage with the body in ways which reflect our interconnectedness with nature. That's essentially where I came to with these phytochemicals. And I think really what they do is they're balancing agents. And in some ways in nutrition, the holy grail, or human health I should say, the holy grail is homeostasis. And homeostasis is basically a state of balance within the body. And that's how I view these phytochemicals, that they are helping us find a state of balance through our genes, through our epigenetics, through our detox pathways, through our hormones, through that hormetic effect. In all this whole myriad of ways, they're helping us find homeostasis. Now, whoops, did I flip over something here? No. Okay. So I also just wanted to share this as well, because has anyone read Robin Wall Kimmerer's work? Yeah. So she is a botanist and she has written 2 books. So she's written two that I've read, Braiding Sweetgrass and can anyone remember? Gathering Moss. That's right. Basically, I think we've got to understand that whilst understanding the chemical, which ties in for those that were here with Dan's talk earlier, whilst understanding that scientific part of food and the chemical complexity of food and really truly appreciating that, and I'm very grateful that we have that information, it's not the only way of knowing. And I think particularly with plants, if we distill them down to their chemical profile, if we still distill food down to its dark matter and its nutrients, we're missing the stories of food. We're missing the traditional wisdom around food. We're missing so much around food that I think is really, really important. And so Robin talks about that there's 2 ways of seeing. And the 2 ways of seeing are basically remembering that we are more than the sum of our parts, essentially, and that science is really, really important, but there are other ways of knowing which tie back to, the stories, which I think is really important. And I certainly know for me, if someone just distilled me down as a human to my biochemistry, I'd be pretty offended, to be honest, because I am far more than that. And yet that's possibly what we're doing with food. So we just have to be very mindful of that as well. I certainly am. And of course, there's dark matter in meat. So again, this is Stefan Van Vliet and Fred Provenz's work and their team showing that the more diverse an animal's pasture is, the more phytochemical richness there is in that food. And that obviously impacts its flavour, but it also impacts its nutrition profile. And as a result of increasing that forage, you're also getting better omega-6 to omega-3 ratios as well. And interestingly, because of these phytochemicals, when someone then is consuming grass-fed and finished meat, what's happening is because of those antioxidants in that, there seems to be a better effect from the omega-3 fatty acids as well, because there's not much omega-3 actually in grass-fed beef comparatively to, say, fish. However, they've shown that it has a measurable impact on us in terms of our inflammation. So why is that? It's probably because of the antioxidants and the phytochemicals protecting that omega-3, because omega-3 it goes rancid very easily, like it oxidizes easily. And this is why sometimes when I see fish oils like in the front of a chemist that's been in the sun, it's like, oh, there's going to be some rancidity in there. And you're not going to get a lot of the benefit of that omega-3, to be honest. But in nature, like an animal's got it covered because they're consuming all these antioxidants that are protecting the fats, which I think is really cool. The other thing as well is that when an animal is eating a diverse forage, like for example Matthew's pigs here, then they're accessing food and eating food that we can't eat ourselves. So I can't go out and eat that pasture to gain those phytochemicals, right? But an animal can. And so by me consuming that animal, I'm getting more unique exposures. Now, this is, we don't really know what the impact of that is, but I think if we come back to the diversity principle, then it makes sense to me to trust the animal's nutritional wisdom and that I will gain benefit from that, provided that animal has been given access to what Fred calls the range and truly those diverse pastures. So they can self-select. And they're also, just while I'm on meat as well, seems to be with nutrients generally this sort of upcycling effect. So we know this to be true for, say, iron, for example, where an animal can eat green grass and that's a non-heme, so not a very absorbable form of iron. We can go out and eat spinach and we can get iron as well, but it's not a very absorbable form of iron. Whereas if we eat the red meat, we're getting heme iron. So that animal's converted it to from non-heme to heme iron. So it's like an upcycling effect of that nutrient, which is more absorbable for us. And some of the very early work from Stefan Van Vliet and Dan Kittredge as well with their beef nutrient density study has shown that there seems to be this upcycling effect with these phytochemicals as well. So when an animal, which makes sense, right? When an animal eats a phytochemical, it goes through their bugs as well. So it goes through their microbiome and then it gets transformed just as it does for us. And some of those phytochemicals that it's getting transformed into seem to be pretty awesome for us as well. So key antioxidants. So that's a really interesting area, I think, to watch this space in. So when we understand that we're still figuring out what is actually in food, it becomes very clear that we can't substitute what we're still trying to figure out. So this is another study from Stefan Van Vliet and his team that looked at the actual nutritional differences in the phytochemicals as well through metabolomics between a plant-based meat and a grass-fed meat and finished meat. And what they showed was that even though the nutrition facts box showed that they were almost identical, when they looked at the metabolomics, which includes the phytochemicals, they showed that there was over a 90% difference nutritionally in those two products. And this is true for so many foods that we try to replace. We try to replace cow's milk and call it almond milk. And even though in some ways really it's not that matched at all, but in some ways a lab might be able to say, I'm going to match the particular macronutrient profile of vitamins. I'm going to add some calcium, for example, to match the calcium found in cow's milk. It is not the same thing because of these differences. And I think this speaks to one of the biggest issues with ultra-processed foods. It's not just that ultra-processed foods have added sugars, emulsifiers, additives, you name it. It's because they're destroying a food matrix. And so for me, it's not just about what's in the food that's damaging to us, it's what's not in the food that's impacting us. And this is true from a microbiome perspective as well. It's something called the missing microbe theory. It's not so much what we're necessarily exposed to that's damaging us, it's what we're not exposed to because it's been lost that's damaging us. Does that make sense? So it's similar, I think, with ultra-processed foods, and something that we need to, as consumers, just be very mindful of, that just because the nutrition facts label might look okay, it certainly doesn't give you the full picture around food. And we know that cooking, combining, fermenting, all have an impact on phytochemical levels as well in food. And I think this is where our food culture and our traditional ways of knowing around food are super duper important. So for example, the Italians have known for a long time, if you cook tomatoes, you're going to get more medicine from it. So there's a compound in tomatoes called lycopene, and when you cook tomatoes, you get a 35% increase in absorption of this lycopene, which is linked to lower prostate cancer risk. So when you cook certain foods, we can get increased bioavailability. That's not a rule across the board. Of course, it's going to impact different nutrients in different ways. But as humans, we've been cooking for about 2 million years. So cooking can have a big impact on these phytochemical levels. Food combining as well. Now, if you look at I love old recipe books. If you look at a lot of these really old recipe books, I love seeing how they've combined herbs and, basically plants and animals. So for example, I put a picture there of salami, and often salami or traditional sausage, pork sausage, has fennel in it. And that's not just because fennel tastes awesome, it's because fennel helps to preserve that meat. So it helps in that so does salt in that preservation process, but it also helps the digestibility of that. So herbs and spices are like digestive aids. They help us digest the richness of that meat. And, lamb with rosemary, there's so many examples that you can think of through history where this food combining has actually been really beneficial for us. And then, of course, fermenting as well can increase some of these secondary metabolites as well, or reduce the ones that aren't so good for us. So, for example, when you ferment beetroot to make it into, say, beet kvass, you're reducing the oxalic acid or the oxalates in that. And that can be a good thing for someone who has a very damaged gut, who doesn't break down those oxalates quite so well. When you ferment tea and add sugar, what do you get? Kombucha. And kombucha is higher in some of these polyphenols than the tea itself. And so again, this sort of traditional wisdom, I think there's just so much to it that is just brilliant. And we've got to not lose that knowledge. Really, really important. So what about farming and phytochemicals? Now, there are quite a few studies that look into the phytochemical levels of different farming systems. Most of them are comparing organic with conventional farming and looking at the phytochemical levels. So there's been a long-standing debate between the nutrient density of organic versus non-organic produce. And to be honest, I think a lot of consumers choose organic because they don't want the chemicals. However, when we look at the nutrient density, there's been conflicting research on the vitamins and minerals of those. Some say they're higher in conventional, some say they're higher in organic, so really conflicting. But when we look at the phytochemicals, when we look at what, as John Kemp calls the medicine of the food, the phytochemical levels are pretty much consistently higher in organic. Some up to 10 times higher, some only 10% higher. But there is a difference between these farming systems for sure. Now, in terms of one of the things I wanted to mention here before I move on is that, again, I think this is where Dan Kittredge's work is so very important because it shows the variability in our food supply so much in terms of these antioxidants, not just the vitamins and minerals. But there is absolutely no doubt that it has a huge impact on not just the nutritional quality in terms of what's measurable, but what's immeasurable at the moment as well. Absolutely massive. So the connection between our ag practices and human health, for some people, and drawing that clear line between this is a nutrient-dense food and these are the human health outcomes of that, in some ways sounds easy, but it's actually not always an easy task. For some people, this is a short road. You know, I pick up one of Matilda's carrots, I eat it, I get health benefits, right? Pretty easy. However, for a lot of people, there are so many steps in the way before they get that food. And I think we're all working at different parts of this continuum. And so where I work at the top of that continuum is really, I think, interesting because for example, if a beautiful nutrient-dense food that Matthew has grown here, I take it home, to a family member of mine, but they are stressed out of their brain, they have a lot of gut trauma and gut damage, they're taking a significant amount of medications that impact upon that digestive process. They have a skewed transit time, which is the time that it takes for food to travel from the mouth to the south, so either very fast or very slow. If any of those things are happening, then, are they really absorbing? Are they really getting the true benefit, of the food? I think in some ways for sure, but not fully, right? And so that digestion and absorption process is really important. And the digestive process, particularly in terms of nutrient absorption, is mind-blowingly sophisticated. Like, it is amazing, just amazing, and so clever and so sophisticated. And so there's a lot going on there that our gut is deciding about, whether or not that's going through or not. The doses, the forms, the ratios, the state you're in when you consume that food. And then we've got, I think, from a human health perspective too, one of the things that I've been noticing a lot that's really important is our perception of food. So I believe that our perception shapes our physiological response to a food. There's a blog that I wrote years ago called Mind Over Milkshakes, and it talks about this concept that how we perceive a food impacts upon the physiological response to that food. And so I think in this day and age and again, these are just the people that I talk to, there's a lot of confusion, there's a lot of overwhelm, there's a lot of fear about food. And that's a concern for me. Because if someone's very scared to eat a food, is it really medicinal for them? Even if I deem that to be medicinal for them, is it truly medicinal? I think it's just a good point, or question. And so a lot of the things that I do is actually try to unpack that with people. And what's the fear around that food? So, for example, we grow tropical apples at home, and I deem those apples to be medicinal because they've got a beautiful microbiome. They're obviously not sprayed. You know, we know that we've tended to that soil for 10 years and it's absolutely beautiful. The flavour is amazing. They're super healthy. And I know that it's brimming with secondary metabolites. But if someone is scared of carbs, and I gift them this apple and they eat it thinking that it's going to harm their health, they're getting a different response to that apple than I am. And again, is that truly medicinal? So I think, you know, for me, as producers, if there's one thing, if I had a magic wand, it would be please continue to tell your stories about what it is that you produce and how you do it to get the real message of food to the consumers, because they're getting very confused. And I think they need to hear the message from the people that actually have their hands in the soil and their boots on the ground. They truly do. So, why does dark matter matter? Now, I think a few things. One, I think it changes our paradigms around food, in the sense that we can now appreciate that food is not just calories, it's not just its vitamins and minerals, it's so much more than that. And so we can hopefully move away from a reductionist way of studying and talking and thinking about food and nutrition. I also think that this research into dark matter is fundamentally game-changing for how we view food as medicine, and hopefully food as medicine programs moving forward as well. Because so far, there are a few food as medicine programs that, not necessarily in Australia, but in the States, that look into the farming practices and track that all the way through to the human health outcomes. Here, we tend to focus on things like produce prescription. So the goal is just get more fruit and veggies in. And it's not really about tracking where they're coming from. And I think in the future, man, do we have to start at the farm. Like 100%. And so I think this dark matter and what that will reveal about farming practices and the medicine of a food is going to bring us back to the farm. And I think that is going to be fundamentally game-changing for how we view food as medicine moving forward, which is super exciting. Really cool. And the final thing as well is I think dark matter brings a story of positivity to food, one of awe, like, wow, that's cool, rather than a fear-based one, which in nutrition, again, there's a lot of fear in terms of the messaging around food. And I mentioned before, I think we need to create space for both the measurable and the immeasurable. So I love that we can measure things, but I think we need to also appreciate the intelligence of nature, and can we really ever truly measure it all? Really? And is there any end to the variation as well? Because if nature is constantly changing and change isn't the exception to the rule, it's the only rule, then it makes sense that a plant is also constantly changing. And so what I did was spoke to Fred Provenza about this and said, what do you think? Do you think that there is an endpoint to tracking this nutrient, this dark matter? And his response was that I think there is no end to the variation within themes, so alkaloids, terpenes, phenolics, etc., of compounds that plants can produce. It takes so little effort or energy for plants to tweak a basic structure and come up with a whole new compound. All the anatomical and physiological machinery is already in place. And so, you know, I think that nature is probably going to be always one step ahead, and I'm really cool with that. I really am. All right, so this is my final slide, and it might possibly be the most important one of the presentation. Now, Wendell Berry says that the land cannot thrive if people who are its users and caretakers cannot thrive. And it is my belief that nature doesn't have a separate set of principles for human health and ecological health. They're one and the same. So these are the principles that I practice by, and I view the world through. But of course, these are nature laws. These are soil principles as well. So in terms of, I think, what is important for everyone here to remember, it's that you already know this stuff, but we don't always do it for ourselves. So I just want to share with you some of the things that some people have said to me over the 14 years of practice, and mostly producers. And these are literally just some of them. So this one was just a couple of weeks ago. Animal welfare is our highest priority on the farm, and yet I've been neglecting myself for years. Rest and recovery is the principle we found to be the most impactful for regenerating our landscapes, and yet I'm not so good at resting myself. I've been keeping grazing charts, carbon levels and soil data for years, yet I have zero data surrounding my own health. I care for the microbes under my feet way more than I do the microbes in my gut. I avoid Band-Aid solutions on farm, yet I have not taken the time to identify and address my own health issues at a root cause level. And the last one, I pay very close attention to my landscape and am a keen observer, but I'm not very good at paying close attention to myself and my own needs. Now, if we're going to have a thriving agricultural sector for many generations to come, then health and well-being must be an absolute priority. So think deeply about the principles and values that you live by and how you can align more closely with those in how you live your life day to day as well. Thank you so much for your time.
All right. Thank you, Stacey. We have 3 minutes until the next session starts, so that is a lucky one or maybe two questions. Who's going to get in?
Welkie. Oh, I'm so glad you asked that question. Okay, so mouth to south, digestive transit time. Some of you in the room are probably really familiar with this one. But basically, our gastrointestinal transit time is really important. It should be about a day in adults. A little bit less, a little bit more, but about a day. And so what you can all do this at home, which I hope you go and do, and email me your transit time results, please do. Love to see them. Basically, you can eat some corn or some sesame seeds. You write down the time and day that you do that. You watch the other end, and you write down the time and day that you first see the corn or sesame seeds and when you last see the corn or sesame seeds. And it's really when you last see them that is your digestive transit time. Now, just because you move your bowels every day, that does not mean you have a good transit time. So case in point, 2 weeks ago, I was speaking to somebody and I love that we're ending on bowels, by the way. And she didn't feel really well and just said it was an incomplete evacuation, basically. But she moved her bowels daily. And so we did the transit time test, and 13 days was her transit time, which is not the longest. The longest is 3 weeks. But 13 days until she saw the corn. And so what we did is I've obviously jumped straight on that. And within a week, she'd reduced her transit time to 4 days, basically with more fibre and more water and some exercise. And she felt unbelievable. And I was like, you just wait till you get to 1 day. Does that answer the question, Jack? Yeah.
Okay, we have time for a very, very tiny question that is not a statement and a quick response.
Yes. Oh, that is a good question. So the question was, does it work in reverse? So if farmers aren't thriving, do they have a sort of negative impact on the land? I'm going to say yes. I think it works both ways. But I also think that nature is so healing. So I can't see that to be the case for very long until things shift, for that person. Yeah.
All right, can we give another thanks to Stacey?
Thank you.